Okay, hi, my name is Kelvin and today we're going to be solving simultaneous equations. So, what is a set of simultaneous equations? So you're all familiar with solving for x. An example of that would be if I gave you the equation 4x is equal to 2 and I asked you to solve for x, you should all be able to tell me that x is equal to a half. And how did you do that? You divided both sides by 4, right? And you got the answer, x is equal to half. So a simultaneous equation, or a set of them, is a very similar concept, except this time you have two equations, and instead of having just one unknown x, you have two unknowns, x and y. So let's look at the example for today. We're given the equations x equals 2y, and we're going to label that 1. Let me write that again. We're going to label that 1, and we're given the equation y is equal to 2x minus 3. Now, I'm sure some of you are familiar with solving these with substitution, but we'll do that afterwards. Now I want to focus on solving these graphically. What does that mean? Solving this graphically is when we find what these equations look like on a graph, we plot them on the graph, and we see where they intersect. So what that means is we see where these two equations are equal to each other on the graph. And at that point where they're equal, that's the solution to this set of equations. So at the end of this, we should have a point with an x-coordinate, x-coordinate, and a y-coordinate, And that point is going to be the solution set of this problem. So, how do we go about graphing these things? Well, I'm sure all of you are familiar with the formula for a straight line, right? Let's write that in green. The formula for a straight line is y is equal to mx plus c. Okay, this is a first order x and y, so it is going to be a straight line, and the gradient will be m, and the height displacement will be c. So let's look at equation 1, and let's do it in orange. Equation 1. And let's put this in orange to avoid confusion. So if we look at equation 1, we want to try and get this in form y equals mx plus c. So let's start by getting all the y's on the one side and see what we have left. So we have x is equal to 2y. If we divide both sides by 2, we have x over 2 is equal to y. So therefore y is equal to 1 over 2x plus 0, right? And that is the form mx plus c. The m is a half and the c is a 0. So the gradient of this graph is a half, which means that for a change in y, every one change in y, there is a 2 change in x, 1 over 2. So if it goes up by 1 in the y, it goes to the right by 2. Okay, so we can use Graph Sketch to do this. I have taken a screenshot of Graph Sketch, and I'm going to plot this on here. First I'm going to make it bigger. Okay, but before I can plot, we actually need a second point to plot from, right? To plot a straight line, you need 2 points. So we've got the first point. Now let's get the second point. You could technically plug in almost any value here, and just solve it. So I could plug in x equals 50 and just find out what the y is, but I want to try and make it easy for myself. So I'm going to plug in y equals 0. So if I do let y equals 0, I have 0 is equal to a half x. And if I times both sides by 2, times by 2, get rid of that, I get x equals 0. So what does that tell us? Well, it tells us that the graph goes through the origin. So I can go back to this graph. Now I know it goes through the origin, so I know that this is a point. And I know that for every 1 increase in y, there is a 2 increase in x. So this is a 1 increase in y. It means that there needs to be a 2 increase in x. So that is the point there. Let's get our straight line. And let's draw it straight through. Cool, and we'll label this graph 1. And you can extend it down to the negative side, which we can do, but you'll see in this example it doesn't actually make a difference because they intersect in the positive. So let's look at example 2, and we can do this in, let's do this in purple. So again, we want to get this equation 2 in the form y equals mx plus c. But what do we notice? It already is in this form, right? We have y equals mx minus 3. So the m is equal to 2 and the c is equal to minus 3, right? So we have the gradient. So a change in y over a change in x is equal to 2 over 1. So every increase in y by 2, there's a 1 increase in x. We can now find a second point by plugging in a value that's going to make our lives easier. In this case, let's again let y equal 0. Let y equal 0. And what are we left with? We're left with 0 equals 2x minus 3. Plus 3 to both sides, and we get 3 is equal to 2x. And then let's divide both sides by 2. And we get 3 over 2, which is equal to 1,5, is equal to x. So we know that when y is equal to 0, x is equal to 1,5. So let's go to our equation. If y is equal to 0, x is equal to 1,5. Cool. Now, let's look at the second point. Let's let x equal to 0. Let x equal 0. If x is equal to 0, y is equal to minus 3. So let's go down to the graph again. X equals 0, y is equal to 1, 2, minus 3. Okay, now let's draw a straight line to correct these. And if we're nice and careful, we find that they intersect over here. Now, just due to human error, it's not quite on the point. But if you were to type these in on the actual Graph Sketch website, you'll find that they do indeed intersect at the point y equals 1, x equals 2. So let's go back and let's summarize this graphically. The point of intersection we'll call P was x equals 2, y equals 1. So that means for this set of simultaneous equations, x equals 2 and y equals 1. Just mathematical lingo, this n is equal to and. It's just an easier way of writing it. So let's check this by actually solving this with substitution the normal way. We'll keep our same colors. So we have x is equal to 2y, x equals 2y as 1, and we have y equals 2x minus 3. Y equals 2x minus 3. So, what is the rule of substitution? We want to get the one side with only one variable, and in this case the easiest one to work with will be 1, right? Because we have the x all alone. So let's take this x and let's substitute the value that it's equal to, this 2y, into the x value here. Bear in mind, it's not always going to be this easy. We got really lucky here. Sometimes you might have to do some manipulations or move stuff around to make it work. But we got lucky. So let's do equation 1 into equation 2. And the subscript I'm writing here, everyone's got their own preference, and some teachers might want you to do it a certain way. It's not super important the way you do it, but be clear and be consistent. Just that it's easy for the teacher to follow, and when you start doing more complicated examples, it's easy for you to check it if you've been really concise. So, 1 into 2. Y equals 2, and let's put brackets so we know what we're doing. Y minus 3. And if we times this out, it's equal to 4y minus 3. And if we if we subtract 4y from both sides, we have y minus 4y equals minus 3, which is equal to minus 3y equals minus 3, which means that y is equal to 1. And what we did there is we divided by minus 3. Okay, now we can label this equation 3. And I'm just going to do it up on the right hand side here so that everything's on one page. But let's do 3 into 1. And we're just going to do it into 1 because it will be a shorter solution. You could also do it into 2, but for the sake of saving time, we're going to do it into 1. So we get x is equal to 2 times 1. Which means that x is equal to 2. And what do you find? You find that x equals 2 and y equals 1, which is the same thing we found here by looking off the graph. So you can do this both ways. And there's actually a third way by elimination that we didn't discuss here that's also can be useful.